Thank you so much for joining me today.
Thanks for having me.
Let's start with your view on the nature of intelligence. And again, it's a broad topic, and because AI is so front and center, I just wanted to talk about how has intelligence evolved over time, and also how did that lead to where we are today?
Wow, well, that's one hell of a way to kick it off. Let me think about this one for a second. The definition of intelligence that I've liked most is the ability to leverage your environment in order to pursue your aims. I think there's other really good definitions of intelligence, which is the ability to compress, the ability to predict. At the end of the day, that's what it's optimizing for. And I think at like the lowest physical level, intelligence is really about uh, producing negative entropy. It's about somehow you're always fighting the second law of thermodynamics, and over the long term you're going to lose. But it's about delaying that defeat by as much as possible, and so somehow turn the disorder that surrounds you into order. And so you turn it into internal order, and you spit out that disorder. That is my favorite definition of intelligence.
I love that. I love how the concept of entropy that you use to describe how that is, and I think that that makes so much sense in the sense that, as you said, in the world, the entropy is always increasing, and here, what we want to do is, at least in the case of intelligence, take that, convert that to something less chaotic, less disorderly, so that it makes sense. No, that's fantastic. Okay, uh, also, across your podcasts and the articles, you mentioned that we are at a point in history where we are witnessing the birth of a new form of life, right? And it's digital life, and it's because of AI and all the developments around it. So, first of all, can you define digital life? Like, how would you characterize it? And also, where do you see this going from here, maybe in the next 5 years?
Yeah. Um, I think that the technical definition of life is something that can grow, reproduce, and evolve, or something like that. Um, Certainly, AI seems to check every single one of these boxes. The image I always use is, or rather, the framing is, if you zoom all the way out from the birth of the universe, the evolution of the universe has been towards greater and greater degrees of self-organization of matter. And so we started with just pure energy, and then subatomic particles, and then atoms, and then molecules, and then cells, and then multicellular organisms, and then brain. Silicon-based intelligence seems like it might be the next step on that march. Um, you know, Regarding predictions, I think it's Yogi Berra who said predictions are hard, especially when they're about the future. Um, but I will try anyway. My timelines for AGI are quite short. I say that there's a more than even chance of AGI arriving within the next 8 years or so. So I think in the next 5 years, things are going to. I think there's a lot of impedance in the world. And so I think the deployment of AGI may be longer than we think. But at first, it's going to look very much like it's looking right now, which is, oh, snap, this is cool. Like, there's a new product that came out. There's a new version of GPT-4, GPT-5, GPT-6. There's vision, there's multimodal. There's these really cool autonomous agents that are starting to work. Like, oh, it's starting to be really convenient, right? I think at first it's going to look like this. And so I think in the next 5 years, we're going to see a dramatic leap in capabilities of the models that we're seeing. I think we haven't even scratched the surface. I think the models that we're going to have in 5 years are going to make GPT-4 look like an Xbox One, make like an Amiga look. It's going to be a very, very, very different sort of model and set of capabilities. I'm a lot more interested over what happens over the even longer term than that. When I think over like a 10 or 20 years time horizon, I think that's when things start to become exciting or worrying.
I loved what you said about how the world is moving towards greater and greater self organization of matter. And I think that there's a certain beauty to that. And obviously, humans have played a role, but also, I think the world in fact moves in that direction. Okay, so you mentioned AGI, the timeline. We'll come to the timeline in a second, but just for our listeners, how do you define AGI?
Yeah. I think the technical definition of AGI is you are as good as the average human at roughly everything. I actually think that it is slightly too high of a bar, and I think that AI can become civilization altering in very, very profound ways much before AGI. The thing that the reason why people are really interested about AGI, the reason why they consider it an important milestone, is because if you have an AI that is better or as good as humans at doing everything, since building that AI was one of the things that humans did, it follows that AI is going to be better at self-improving than humans would. And so by that logic, since it can self-improve, it means that it could take it, call it a day to make its next version. And then, well, since the next version is better, it would take it 20 hours to make the version after that. And well, the version after that would be perhaps 12 hours. And it's the limit. You could imagine this AI self-improving on the rate of like milliseconds per self-improvement, and so you get to that thing that's called the intelligence explosion. I think again AGI is too high a bar because in order to enter that recursive loop of self-improvement, you don't need to be as good as humans at everything. You only need to be not only even as good as humans. You need to be good enough at only a certain limited set of things, which are chip designs, AI research, and software engineering. If you are good enough, again, that doesn't mean better than every human, that doesn't even need to mean better than the average human. It just means good enough to make a positive contribution. If you're good enough at any of these three things, then you could enter a recursive loop of self improvement.
Right. That's an interesting point. And if you think about, can a machine create another machine that is more intelligent than itself? And if that in fact is true, then you can imagine a situation where quickly that machine creates the next one and the next one, and it just explodes from there. Also, you said 8 years, right? So for the timeline, what needs to be true? Like, what needs to happen in those 8 years so that at the end of the eighth year we'll say, "Hey, we are at the mark. AGI, we've achieved that."
Yeah, I think you'll know it when you see it. I actually am not even sorry. I take that back because I think people can move the goalposts at a breakneck speed is pretty remarkable. So I think from a technological standpoint, what needs to happen in order to get there is there's multiple compounding loops here, which is one, there's just like an economic loop where it's like we're pouring more and more money, billions of dollars into that. Then there's Moore's law, which keeps a pace, and the GPUs are in fact getting better and better and better. By the way, these two loops are also interwoven because as volumes increase, then you climb up the experience curve and you get better at producing better GPUs and cheaper. And there's more R&D going into GPUs and so forth. There's architectural improvements to the models. I don't think the transformers are the final architecture, and there are extremely exciting competing architectures coming out that may be orders and orders of magnitude better than transformers. There is inference optimizations. I think, even if we keep everything else constant, quantity has a quality of its own. And so if we could make inference 10x faster, well, that in and of itself could make a pretty big qualitative jump at the end of the day. I think quantization is certainly interesting. I think distillation is certainly interesting. I think training optimizations are also certainly interesting. I think we're learning a lot about the kind of data that goes into this training. I think, again, just going back to the architectural optimizations, if you look at RLHF, I think that the kind of RLHF that gave rise to the models that we use and love today, the GPT 3.5s and GPT 4s of the world, I think this is the worst that RLHF is ever going to be. RLHF is improving very, very rapidly, and we're already starting to see versions of RLHF using DPO instead of PPO that is extremely promising. RLHF as a whole is becoming more and more efficient. I could go on and on. Basically, it's like there's all of these curves that stack on top of each other that I think lead to that Lollapalooza effect of huge improvements over the next few years.
Amazing. And if you look at the perception of AI, if you do a survey, Many people are excited. I am very optimistic. I'm in that camp. I love what technology can do for humanity, especially AI. And there are also people in the camp where they're worried about AI. They're like, hey, we should, this thing looks fast and dangerous. We should rein it in.
What I will say is that I very much sympathize with the people who worry. And by the way, at this point, some of the world's greatest AI experts, like Jeff Hinton, are extremely worried, and I think there is reason to be. If you were looking for a historic example of a time when a smaller species was subjugated to a dumber one, I think you would very much struggle to find this kind of example. And so we're giving rise. I think intelligence is the most powerful force of the universe. I think it is what made us the dominating species, and we're giving rise to a species that is going to be orders of magnitude more intelligent than us.
Right. Uh, Shifting gears a little bit, for listeners who don't know, can you quickly explain what Lindy AI does?
Yeah. So we are building an AI employee over the long term, and frankly, not even that long term. I think these AI employees are going to be sophisticated enough that they can manage entire companies like autonomously. I think we're going to have AI autonomous companies made of thousands and thousands of AI employees just pursuing goals. And so we built a platform that lets you create as many of these AI employees you want. And you give them a goal and you give them access to certain tools and applications. And then they pursue the goal that you want using the tools and applications that you gave them access to. So these AI employees can be support agents, they can be recruiters, they can be marketers, they can be salespeople. Soon they'll be able to make phone calls, and so on and so forth.
Amazing. Can you just talk about outside of Lindy? Let's say you're talking to a customer, like a big company, and you're advising them. Like, what do what do customers really want from an LLM product?
Yeah. I think especially business customers don't really know yet. I think they're very aware that something important is happening, but they're sort of confused by how fast things are moving and the breadth of offering that's out there. They don't even really know how to evaluate these offerings. So I don't exactly know that they know what to look for. If I had to advise them on what to look for, I would tell them look for something that just delivers value right now. Be sort of greedy, because if it delivers value right now, I think it's likely that it will deliver even more value in the future. I would urge the very big enterprise companies to be more willing to experiment with smaller players earlier than they have in the past. I totally understand the concerns about like, oh, they're going to be a viable long-term partner, but the truth of it is that things are moving so rapidly right now, and the companies that are really building the groundbreaking stuff are going to be startups. And so I would recommend like companies to just fuck around and find out, and just implement a lot of things and work with a lot of things and try a lot of things, and see what's working for them. I would let 1,000 flow or bloom.
That's amazing. And actually, that's a good segue into my next question. If you look at the array of foundation models available, on one end we have very large foundation models, very generic. They address a whole bunch of different use cases, and also on the other hand, we have a large number of smaller, like specialist models for a specific task or use case. And the world, there's place for both. But how do you think this market will pan out in terms of, will the world need more of the large generic models? Will they need the smaller specialist models?
Yeah. I don't think it's an either or, but by and large, I think the larger specialist models are going to dominate for the simple reason that they're going to become cheaper and cheaper. And for a lot of tasks, we're going to reach decreasing returns, meaning for most tasks that people care about, I'm not talking about the stuff that's like solve global warming and cure cancer and all of that stuff. But like when you're talking about like writing my email and triaging my inbox and so forth, I don't need God to write my email. And so, okay, like 3.5 is already doing a pretty good job at that. And 3.5 is going to get exponentially cheaper from here, and it's already basically free. And so, really, I think the biggest advantage of using a specialized model here would be the capability of the model. But again, 3.5 is doing a reasonable job. And if I cache out prompt it with my writing, it does a really good job. It's the speed and the cost efficiency of the model. But again, like the big models are all these so good and so cheap and so fast that it doesn't really matter. So my money on the long term is over like the big general models.
Right. And early on, you talked about chips. And in AI, you cannot talk about chips and not talk about Nvidia. So I want to spend a minute just talking about Nvidia. It's been a huge driving force behind this AI revolution, and obviously they supply the GPU, the flagship GPUs to the entire AI world. Now, obviously, big company, hugely dominant. So at this point, what are its strengths? Meaning, why are they staying dominant? And also, more importantly, what are the angles of attack? Meaning, if there's an upstart who's thinking about, okay, there's the weakness, there's Nvidia's weakness, what would that be?
Yeah. Well, first of all, it's very hard to be an upstart in semi. Very, very tough
Right,
market to
right,
break into. The strength is CUDA. That's the real moat that they built around the chip. The silicon is not really the moat. CUDA is the moat, and it's just extremely hard to catch up on. And if you look at the developer experience on competing chips like AMD's chips or even Amazon's chips, it's very very behind Nvidia's experience. Sometimes, frankly, it's sort of embarrassing how much behind it is. If I was to start a semi company, which I'm not, I would look into. I'm very excited right now about the companies that are basically burning LLMs onto a chip. I believe Huawei is working on something like that, or maybe Qualcomm. But if technically you could burn a very large model onto a single chip and get basically an entire forward pass to move at roughly the speed of light, and I think that could make a huge difference for a lot of people.
right. And of course, CUDA is Nvidia's platform, the software platform that enables uh, people to leverage that hardware to build like general purpose compute applications. So basically, Nvidia's hardware, obviously very complicated, it's important, but even more important, even more critical to their dominance is their software stack on top and what they've built. I think that's a fantastic point. And also looking forward, the world is consuming compute, so much compute. There's hungry for AI compute all the way, and we're producing a lot of chips, and there are cloud services being offered, infrastructure platforms being offered. So if you look at the AI compute market, software and hardware, how will that market shape up? Meaning, will the incumbents take all of it? Is there room for a startup to build not maybe not the chip, but anything else on the compute side?
I mean, right now, Nvidia is basically a monopoly. They seem to have a very safe chokehold on the market. I
Yeah.
foresee that's going to remain the case for the foreseeable future.
Right. And if you look at the software infrastructure side, meaning obviously Nvidia supplies the chips, and say big three cloud providers, they'll provide all of the cloud compute you need. What other infrastructure like software products does the world need right now? Do we need more frameworks, more speed ups, more training tools, more testing tools? Like what do we need on the infrastructure side today?
Yeah, there's a lot of work being done around evals, like evaluations of your product. There's a lot of work being done around guardrails that you can put around your LLM-based product. There's a lot of work being put around observability. There's a lot of work being put around automatic prompt engineering. I will say I am feeling sort of bearish on LLM ops as a category. ML ops as a category didn't pan out nearly as well as anyone expected. And LLM ops, I feel like that at this point there's more LLM ops companies than there are actual like large language models in production. I feel like there
Right.
might be a lot of concentration in the large language models that are in production, and so the market size in dollars might be big, in companies might be small, and you actually don't want a market size in companies that is too small because then you have a lot of revenue concentration, and also you run the risk of these companies just building their internal tooling. And we're actually seeing quite a bit of that already happening. I also have like a personal philosophical beef with LLM apps and tooling companies because they strike me as what Peter Thiel calls, right? It's like you're confident that everything is going to pan out well, but you don't know exactly in what way. And so you sort of spread your bets and you make this meta bet that's like, I'm going to bet on the category and build this thing. And I'm like, man, the future needs to be built right now. There are too few builders, and we need everyone we can to actually come over to the application layer. The water is good. So I
Right.
wish fewer people were making this kind of bet, and more people who are actually trying to take a definite optimism view and a strong view of, hey, what is the future going to look like, and how do we accelerate the future coming about?
That's amazing. It's actually a wonderful point here is that you need ops when there's stuff that's already
Right.
built and it's mature, and then you want to monitor it. And again, if you look at the cloud compute when it came around, first companies were built, the cloud was built, companies were built, and then after once it was mature, semi-mature, then Datadog came along and said, "Hey, look, there are so many like servers and applications and micro, like we need a platform to keep an eye on the many things." Then maybe it made sense. Like, but they didn't like even before you even before AWS. If you set up a Datadog, then it's just kind of doesn't make much sense. All right, let's shift gears to AI agents. And given that OpenAI has been providing amazing models and people have been building AI agents, AI agent platforms, many different like little tasky use cases. So, step one, can you just define what an AI agent does for our listeners?
Yeah. There's a lot of definitions, and according to some of them, regular software is basically agents. But I like to describe it as it's an autonomous entity that is given access to tools and can use this tool to pursue goals in the world. That's an agent for me.
Right. And if you look at an AI agent, let's talk about consumer first. So, what needs to be true for an AI agent to be useful to a consumer?
Yeah. Well, it needs to pass the variability threshold. It needs to be sufficiently reliable. I think most importantly, and deliver more value in your life than it's costing you, either in money or in stress because you're worried that it's going to screw up and whatnot. And so, basically, that variability threshold is a function of how high the stakes are for the task that you're trying to perform, and how much value does the agent provide to you when it's delivering that task correctly. And so there is a way to lower the stakes greatly by introducing a human in the loop. And so the agent is not fully autonomous; it just submits the work to you as a human, and then you review it. Which I think is the form that takes the most successful AI products out there right now, which are basically Harvey for law and Copilot, GitHub Copilot for code. They have very high value because law and code are expensive, and the stakes are high in fine. But since there is a human in the loop, like the lawyer reviews the work that Harvey does for them, and the engineer Copilot literally lives in the repository, and so you see the kind of code that's being written live. Since there is a human in the loop, the stakes are actually lowered a great deal. So that's what I think is needed for the AI agents to deliver value to you.
Right. I have one final question before we go to the rapid fire round, and it's around the discussion around where is the value accruing like within AI. Like some people say that, hey, big companies, big tech companies are going to take all of it because it's mostly you need a lot of money, a lot of resources, need years of expertise. And there are people on the other side who say that, hey, incumbents have always existed, it's true for every startup ever, but that will not stop startups from finding angles of attack and becoming the next big company. So when it comes to AI, obviously it's a more nuanced answer. Where are the opportunities for startups, and what areas will be dominated by incumbents?
Yeah. Um, you know, my mental model of this is that incumbents win whenever you can tack the innovation on top of your existing product. And startups win whenever the existing product needs to be rebuilt from scratch because the innovation cannot be tacked onto. It's just at the core of the new product. I think The great example of that is, for example, Figma. Multiplayer and browser-based editing is not something that Adobe could tack on top of any of the products. They would have had to rebuild an entire product from scratch, and that's what they tried to do with Adobe XD. But once you try to do that as a big company, you arguably are not at much of an advantage versus the startup, and are arguably at a disadvantage, right? Because your existing customer base and your existing legacy, both technical legacy and institutional legacy inside your company, are actually holding you back and preventing you from moving fast and from innovating and from building this new product fast. The other example of that is mobile with Salesforce. Elad Gil is always tells the story of when mobile came about, a lot of startups were pitching the mobile CRM, for Salesforce salespeople who are on the go and so forth. And it turned out that the mobile CRM was actually Salesforce. Because you could actually just tack that innovation on top of the existing product. So when it comes to AI, I think very often you can actually tax the innovation on top of the existing product. So for example, Zoom is doing a reasonable job rolling out AI into their product and giving you meeting summaries and so forth. But I think there are a lot of products that really need to be reimagined from the ground up. So for example, AI agents, in fine, you could, if you really had to make them fit in a category, it would be the automation category. But when I look at the big automation players out there, I don't see a single one of them where AI fits neatly on top of that product. And when I look at the way we have built Lindy in a way that I think is native to this new AI paradigm, I view an architecture that I think is very alien to what I imagine is the architecture of these other automation products.
Amazing, and I love that viewpoint from Elad Gil. He was actually a guest on the podcast a few months ago, and it's I think what you said about can you just add that innovation on top of an existing product, and if that's easy, then yeah, incumbents will just take it because they have distribution, and that's what counts. Get that thing into the hands of the customers, so startups, they don't have an angle. But I think that's a fantastic way of looking at it. All right, with that, we're at the rapid fire round. I will ask a series of questions and would love to hear your answers in 15 seconds or less. You ready?
Let's do it.
All right. Question number one. What's your favorite book?
Atlas Shrugged.
Perfect. All right. I think Atlas Shrugged. It's a fantastic book. Long, and obviously it's it's beautiful. We can talk about that in another episode, but love that. All right. Next question. What has been an important but overlooked AI trend over the last 12 months?
Quantization.
Right,
Perhaps you want more. I think it's a very big deal that we're about to get so much performance out of such small models. Yeah, I think everybody
Right.
expected only the giants to be able to create these models, and it turns out that you can get really, really good performance on models that run locally. I did not expect that.
Amazing. Next question. What type of knowledge professional is most underserved by AI right now?
I think they're all equally underserved, except for lawyers and engineers. I think we haven't even scratched the surface yet.
Right. Amazing. Yeah, that's great. All right. Next question. What separates good AI products from the great ones?
I think a deep understanding of the problem you're trying to solve and a willingness to nail every single detail in order to provide like a magical experience from beginning to end, and a reliable experience, most importantly.
Right. Next question. As a founder, what have you changed your mind on recently?
I think the AI safety debate is the biggest thing I've changed my mind on. I used to share a lot of people's skepticism about it, and as the facts change, I changed my mind.
What's your biggest AI prediction for the next 12 months?
I'll keep this one to myself. I think AI agents. I think people don't quite still realize how important AI agents are going to be.
Awesome. All right. Last question. What's your number one advice to founders today?
Fuck around and find out.
Perfect. I think that's a perfect place to end the episode, and I think that's where we are in the AI phase anyway. Like you just had to experiment, like keep doing things, and some will work, some won't. But the point is that exactly that. Just keep doing stuff instead of debating and endlessly arguing about a whole bunch of things. I think that's that's a great way of doing it. Flo, this has been a fantastic episode. Loved your candid viewpoints on so many topics, and I'm glad we covered many topics here. So thanks again for coming onto the show and sharing your insights.
Thanks for having me, Pratik.
Perfect. Hold on.